Welcome to Ms. Parv's Flipped Classroom. We're going to study factoring by grouping today. Remember, factoring is when you break something down into things that multiply to give you your answer. And our objective is to factor higher degree polynomials. This would be a third degree polynomial with 4 terms. The first thing we're going to do is check for greatest common factor. 3, 12, 2, and 8 do not have any common factors except for 1, and this term does not have an n, so there is no greatest common factor. So the next thing we're going to do is group the terms 2 at a time and find the greatest common factor for just 2 of these, ignoring the other 2. So the greatest common factor for this would be 3n squared, so we factor that out. The greatest common factor for just these 2 would be 2, so we factor that out. Now we notice that the term or the expression in the parentheses is exactly the same, so we factor that out. So we have this times 3n squared plus 2, and this would be our answer. So the got it for you to try, we have 8t to the third plus 14t squared plus 20t plus 35. The first thing we need to do is check for greatest common factor. 8, 14, 20, and 35. There is no greatest common factor, and this term doesn't have a t. So we'll go straight to our next step, which is to group these 2 at a time. And then we're going to look for greatest common factor just between these 2. 2t squared will go into both of those, so that would leave us 4t plus 7. 5 will go into both of these terms, so that would leave us 4t plus 7. Once again, we notice that what is in parentheses is exactly the same, so we can factor that out. And then what we have left over, 2t squared plus 5, goes in the second set of parentheses, and there's our factored form of this polynomial. The next example we're going to factor completely. The only difference is this problem is going to have a greatest common factor that we can factor out at the very beginning, and then we'll go through the steps just like we did before. So we look at these 4 terms and notice that 4q will divide evenly into each one of those. So we factor out the 4q, and it leaves us what we have in the braces here. And then we're going to take this and group it 2 at a time, just like we did up here. So we group these 2 and these 2. We look for a greatest common factor for just these 2, and we find q squared. And the greatest common factor for just these 2 terms is a 3. Once again, what's in parentheses is exactly the same, so we can factor that out. And that gives us 4q times q minus 2 times q squared plus 3 as the answer. And if we were to multiply all of this together, we would get this polynomial that we started with. So the got it for you to try is the same thing. First thing we want to do is look for greatest common factor. 6, 9, 12, and 18. So we know that 3 will divide evenly into each one of those, and each one of them has at least one h. So our GCF is going to be 3h. So we can divide each one of these by 3h. Remember, the 3h is going to go out here, and we'll have 2h to the third plus 3h squared plus 4h plus 6. So we've done the greatest common factor right there. The next step is to group these 2 at a time and look for a greatest common factor just here. Well, between these 2 terms, the greatest common factor would be an h squared, and that would leave us a 2h plus 3. With 4 and 6, the greatest common factor would be 2, which would leave us a 2h plus 3. And now we notice that what is in the parentheses is exactly the same in both of these expressions. So we have our 3h that we factored out at the very beginning, our 2h plus 3 in our parentheses, and then our h squared plus 2 that we had left over. And that would be our answer.